Hey guys, welcome to the HackedExistence tutorial on building JHewitt's WarDriver. So everything you need to know about this project can be found at wardriver.uk. Basically, this is a device that's going to capture and log all of the Wi-Fi and Bluetooth devices that we come into range of, along with GPS coordinates and UTC timestamp at the time of discovery of each device. It's going to package that all up into a text file that we can upload directly to wiggle.net, allowing you to compete with WarDrivers from all over the world in a ranked hierarchy of who can discover the most devices. Additionally, you'll be contributing all of your discovered devices to the wiggle.net database, which is a searchable database that allows you to pinpoint the physical location on the globe of all of the discovered devices from all over the world. In this video, we'll also be adding the optional LCD that'll give you real-time stats, as well as an optional GSM radio that will capture and log all of the cell sites that you come into range of, and an optional temperature sensor that will record and log the ambient temperature at the time of each device's discovery. We'll wrap up the whole project by installing it into a 3D printed case and get you up and running on your war driving journey. So let's jump into the bill of materials. Alright, so the heart of the project is the JHewitt WarDriver Rev 3 PCB. I got this on wardriver.uk for $4, and this is what everything is going to solder to. Alright, next we're going to need two ESP32 WRoom32Us, and these are the ESP32 boards that have the external antenna jack. And this is going to be the heart of the operation, so they work in a master-slave configuration where the slave is constantly searching for Wi-Fi and Bluetooth devices, and then telling the master about them, and the master writes them to a micro SD card, as well as hosting a wireless access point that you can connect to from your phone or your laptop to pull the text file of all the discovered devices, so you don't have to physically remove that micro SD card and plug it into something. Next, we're going to need a way to store that, so I'm using a 16 gig micro SD. If you go much bigger than that, you're going to run into problems. I recommend doing a 16 gig micro SD, and I got that for $5. Next, we're going to need a way to read and write the micro SD card, so I'm going to use a 6-pin standard SPI micro SD reader writer, and I got this in a pack of 10 for $10, so this costs about $1. After that, we're going to need a set of external antennas. I bought 3 different kinds so that I can try them out. They're different levels of dBi, so I can compare them to each other. Once we install this, we can just swap them by screwing them on and off of the RPSMA. But basically, you're going to need a set of dual band antennas with an IPEX connector or UFI connector on one side and an RPSMA on the other. After that, we're going to need the ATGM336H GPS module. This is a little 5-pin connector, little tiny guy again with a little IPEX adapter. It comes with this external antenna. And this GPS module cost me $16 on Amazon. So this is the optional SIM800L GSM module. You don't have to add this, but I'm going to go ahead and do it. And it comes with a little antenna that we'll solder on. It also came with an external antenna, but we're not going to use that in this project. We're going to use the little wire antenna that it comes with. Of note is you do not need a GSM card for this to work. But what you do need for that GSM module to work is an 85C Zener diode. So here are the ones that I got off of DigiKey. They were a couple bucks, so I bought a 100 pack of them. I think it was like $8. You'll need one of these to get your SIM module running. All right, another optional component that we're going to add is the thermometer. So this is a DS18B20 thermometer. I got a 10 pack of these for $9 on Amazon. And in order for that to work, we're going to need a 4.7K ohm resistor. I got 100 of these for $6 on Amazon. Another optional piece that we're going to add is the SSD1306 display. I got this for 5-pack for $13 on Amazon. Came in this little box like this. So something to note is that on my first round, I purchased these IdeaSpark SSD1306 displays, which look exactly the same, but I could not get these to work because these work with the U8G2 library, and we need to make sure that we get a display that is compatible with the Adafruit SD1306 library. So again, I picked up the ones that look like this and come in this little box here. Once we get all this stuff soldered up, we'll mount it all into this 3D printed case. I got the files off of Thingiverse, which was linked to, again, from wardriver.uk. And we'll assemble that with 4 M2x16 screws and 4 M2 nuts. So let's jump in. All right, so we're going to start with an ESP32, and we're going to put it over the words JHewitt on the PCB here and run those pins through the holes. So now we've got the ESP32 mounted on the top of the board with the micro USB coming out to the left, and now we'll solder all of these pins on from the bottom. All right, now we can see that the ESP32 is soldered on to the bottom of the board. So the next step I'm going to do is optional. You can skip this if you want, but we're going to install the thermometer. So I'm going to use the 4.7K resistor, and I'm going to put it on the two holes on both sides of 4.7 there, so that it covers that 4.7 written on the PCB. Then we're going to take the thermometer, and you can clearly see there's a flat side. That flat side is going to point in towards the PCB. We're going to drive those 3 pins. We're going to spread them out, drive them through those holes. Then we'll fold all the pins over, solder them on the bottom, and cut off any excess. Alright, so now we can see that we've got our thermometer and our resistor soldered onto the board. So the next step is going to be the GPS unit, and we will notice there are 5 pins here along with 5-pin header. We are not going to be using the PPS pin, the square one on the end, so I'm going to start by cutting one of these pins down. And now we have a 4-pin header, and so I'm going to drive this through the side that has the sticker. We're going to drive the short end through the board so that when we mount it, the IPEX socket for the external GPS antenna will be facing up so we can get to it. And so now I'm going to go ahead and solder these 4 pins on. All right, now we've got the 4 pins soldered into our GPS radio. So the next thing we're going to do is take our board and flip it over, and we'll see the GPS unit here. We'll notice there's a 3 and a G. So that 3 is going to align to the VCC pin on my board, which is 3 volts in, and the G will align to ground. So we're going to make sure that we line those up and drive them through. And then we'll flip the board over to the top side, and we'll solder these 4 pins on. All right, now that we've got our GPS radio all soldered onto the bottom of the board, I'm going to flip it over and trim down these pins here so we can make room for some other boards. All right, now that those pins are all nice and trimmed down, we're going to prepare the GSM radio. So this is the SIM800L, and we're going to use the little antenna that it came with. And it's going to go into this square socket here directly underneath of the external antenna socket. And we're going to align it diagonally across the top of the board there. I'm going to flip it over, and we're going to solder that antenna into place. All right, so now we can see that we've got a nice clean solder joint on our antenna here. It runs diagonally across the board. The next thing we're going to do is use the header pins, and I'm going to cut out 5 more for the remaining slots there. All right, and then I'm just going to drive the short end of the header pins through the side that has the SIM card slot. And now I'll flip it over and solder on all these. All right, so now that we've got the header pins soldered on to our GSM radio here, these are going to install over where it says SIM on the board, so we'll drive those pins through. And then what we'll immediately notice is the ability for the SIM card slot here to contact and short out one of the pins from the GPS unit. So this is where it's going to get interesting. We're going to mount it at an angle like this. And basically my method for achieving that is to roll up a piece of paper towel and shove it in there, then flip it over and solder on those pins. So let's go ahead and give that a try. All right, now that we've got our GSM radio pins all soldered in there, and we can see that it came out at an angle, I'm going to go ahead and remove the paper towel. We can see that it's held in place now, and there's no ability to contact here. So the next thing to do is get this SPI micro SD reader up and running, and this is going to take 6 pins. So I'm going to use the short side of the headers on the top where the micro SD slot is, and we'll drive those through, flip it over, and I'm going to solder in these 6 pins. All right, so now that we've got our header pins soldered onto our micro SD card reader, we're going to plug in the micro SD card. And then we're going to plug this onto the board over the label for SD. And we're going to again see the need to angle this to be able to get that micro SD card in and out. So I'm going to again use the paper towel trick, and I'm going to shove a paper towel up under here to hold it at an angle like this, and then I'll flip it over and solder in these pins. All right, now that we've got our micro SD card reader soldered on, I can go ahead and remove the paper towel, and we can see again that these got soldered at an angle so that that micro SD can come in and out of there. The next step is to install the 85C Zener diode, and this is only if you installed the SIM radio as well. Basically, what we can see on the Zener diode is that one side is marked black, and so this D1 on the board here has an arrow that's going to point to the black side. So I'm going to go ahead and install that Zener diode through those 2 holes there. All right, and I'm just going to hold it snug up against the board there, and I'm going to fold these 2 tails over. And now we'll solder those 2 on and cut the tails off. All right, now that we've got our Zener diode all installed and looks pretty flush mounted with the board there, the next step is going to be to install the display. This is optional, you don't have to do this. But basically I'm going to use these 4 color-coded wires I have here. I'm going to cut the ends off, I'm going to strip them back, and I'm going to drive one each through each of these 4 pins, flip it over, solder them on, and then I'll cut off any excess. Alright, so now we've got our 4 wires for our display soldered in, and I'll usually take a picture of this just so that I have a reference for what color goes to what pin. I'm going to go ahead and plug these in for now just as a temporary solution. Later on we'll come back and solder it in for a more permanent solution. But SDA, I'm going to wire to the yellow SDA wire. SCL is going to go to SCK. VCC will go to the 3, and G will go to ground. All right, now we've got our screen all attached so we can get this thing up and running, make sure everything works before we commit to soldering. The final thing to solder now is going to be the remaining ESP32, and it's going to go over this slot here with its micro USB pointing down towards the first ESP32. So I'm going to kind of move the wires out of the way and get pins all lined up. And once again, you'll see this is a board we're going to have to angle, not only to leave clearance for these wires coming out from underneath of it, but also keep in mind we're going to have to plug a micro USB plug into that micro USB socket a little later on to flash the firmware on here. So once I've got this all to a nice place, I will flip it over and solder in all these pins. Alright, so at this point we should have a fully assembled board with all of our components soldered on. The next thing is going to be to flash the firmware on our 2 ESP32s. So keep in mind this one is referred to as board A and this is board B. So I'm going to start by plugging a micro USB plug into the USB socket on board B. And then I'm going to plug the other end of this into the computer and we're going to flash board B's firmware. Okay, so to begin flashing the ESP32s, we're going to start on the WarDriver.uk website, and we're going to follow this link to the official GitHub repository, and we're going to start by pulling down a copy of that, and we'll go ahead and unzip that, and inside the folder here, inside of B, we're going to load up that Arduino sketch. And now back here on the GitHub, we're going to scroll down here, and we're going to copy this URL. We'll switch back to Arduino, we'll go to the preferences, and we'll paste that URL into the additional boards manager's URL. Then we'll go to tools, boards manager. And in here we'll search for ESP32, and we'll install the ESP32 by Espressif. Alright, now that the ESP32 boards are all installed, we need to install our library dependencies. You can look in libraries.txt to see the exact versions, but I'm just going to install the latest versions of all these, and that should work. So I'll do that by going to Sketch, Include Library, Manage Libraries, and I'm going to type each one of these libraries in and get them installed. Alright, now that we've got all of our library dependencies installed, we basically need to run through and make sure that all of these settings are set. So once again, I will go to Tools, Board, ESP32, and we'll do the ESP32 dev module. And I'll just validate all of the rest of these. A couple of them need to be set, but I'll make it match what all these say here. Alright, now that all of our settings in the tools menu matches what's on the GitHub, so I'm going to plug in the ESP32, but first I'm going to look at my list of ports here and take note of what's there, and then I will go ahead, click off that menu, and plug in the USB for board B. And now that we have board B plugged in, if we go to tools and port, we'll see there should be some new ports here, so I'm going to do this USB serial. And so now I have the ESP32 dev module on my USB serial. And now I'm going to hit upload. And it looks like I selected the wrong port, so I'm going to go back to Tools, Port, and I'm going to do this SLab USB to UART port instead and hit upload again. Alright, and now that we have board B flashed, I'm going to pull out the micro USB cable from board B and I'm going to plug it into board A. And now back on the computer here, I'll close out the sketch for board B. We'll go back to where we pulled down the repo, and we'll go into the A folder and open up the sketch for A. And now we'll once again make sure that all of these settings match here what's on the GitHub repo. So I'll go to Tools, Board, pick out the ESP32 dev module, make sure all the rest of these align. Yep, that all looks good. And so once again, I'll do the slab USB to UART port, and then we'll upload. Alright, and now that we have board A flashed with firmware, I'm going to unplug the WarDriver completely, and we'll get the micro SD card set up. So down here in the first time setup, there's this GSM cell towers database. This is optional, but this will give us GSM location to use in place of the GPS module. It's a neat little fallback to have. So basically what I'm going to do for that is download the files on the link from this page, and I will just grab the latest cells.zip. And now we'll go ahead and unzip that. And now I'm going to pop the micro SD card into my MacBook here. And we can see inside of this cells folder is all of these CSVs. I'm just going to copy this whole cells folder, and I'm just going to paste it right in the root of the micro SD card. Alright, now I'll go ahead and eject that micro SD card. I'll stick it back in the WarDriver, and we'll see if this thing runs. Alright, now that we have everything installed, I'm going to use a micro USB plugged into a battery. I'm going to plug it into board B and power this thing on. We'll see both of these lights come on. Eventually the GSM will start flashing its little LED right there. And we'll see that the screen has come on and everything looks good there. So now that we've tested it and everything looks like it is operational, we're going to do our final solder job. I'm going to take note of which color wires are going to which pins on the display. I'm going to pull this off. I'm going to cut them here. I'm going to strip them back. And then up here, I'm going to snip the 4 pins. I'm going to use my soldering iron to heat them up and try to pull them out, try to clean up those holes so I can take those 4 wires, run them through, solder them in, and trim it down. And we got to make sure that those wires come from the bottom of the display, because the next step will be to mount the display. And so this part has to be flush. So let's go ahead and do that. Alright, not a super elegant or pretty solder job, but it works and it seems to be pretty durable. The screen is all running, so we'll cut the power. The next thing we're going to do is connect the wires that came with the antennas. So I'm going to use these UFL IPEX connectors. We're going to connect that to the socket on the 2 ESP32s. We'll flip it over and plug in the GPS antenna to the socket on the GPS board. Alright, now that our antenna wires are all installed, we'll set this aside. And we'll get our 3D printed base along with the 4 M2 nuts. And I'm going to stick the M2 nuts in each corner, and I'm going to press them in with a pair of pliers. Alright, with our nuts all pushed into the 4 corners, now we can drop our board in here. We'll be careful to bring the GPS antenna up and through the little hole. Alright, now that that board is all snug in there, we'll take our middle piece, being careful to align up the holes and make sure that this is where it needs to be. And we'll screw the RP SMA plugs through these holes in the top here. Okay, so now that we've got everything all installed into the case, the next step is going to be to take the protector off the screen. And now we're going to install the screen into the top mount here. So you can see that there's little cutouts where it's going to fit in. It's going to fit in just like that pretty perfectly. And now I'm just going to use some hot glue to hot glue it into place. All right, now once that hot glue is dry, I'm going to flip this over and just kind of slam this on top. And finally, we're going to use 4 of these M2 bolts to hold it all together. Alright, now that our WarDriver is all assembled, we can screw on the RPSMA antennas. Alright, now we'll use the micro USB to give it power through the micro USB slot. We're powering board B here. And of course, we glued the screen into place upside down. So I'm going to take it apart, flip the screen around, put it back together. Alright, we're now put back together, powered up, proper screen orientation. Let's jump over to the computer. Alright, so on initial boot, it's going to throw up a wireless access point, and this is what it says on the screen to connect to. The password is wardriver.uk, all lowercase. And once we're connected, we'll go to 192.168.4.1. And here we can do a little bit of setup. If we want, we can tell it about our home network and tell it to automatically connect when it's within range so that we can interact with it. I'm going to continue without doing a network. And basically at this point, we can set a fallback network. So I'm going to call it WarDriver, and I'll make the password WarDriver, and I will submit. And now we'll cycle the power, and what'll happen is when it boots, it will give you 60 seconds to connect to it and control it from there. Once that timer runs out, it will just start doing its normal thing, logging devices that have been discovered to the micro SD card. Alright, so at this point you guys should have a fully assembled and functioning JHewitt WarDriver.uk device. We can see this one's already pulling Wi-Fi devices, Bluetooth devices. It's already got GPS coordinates, a temperature, pulling the timestamp, even seeing 2 GSM cell sites. So get out there, start collecting devices, and I will see you guys on wiggle.net. As always, stay tuned, and thanks for watching.